Hey everyone, welcome back. Today we're taking a deep dive into electrospinning.
Electrospinning?
Yeah, it's this super cool way to make these crazy small fibers called nanofibers.
Huh.
And get this, these nanofibers, they're like 1,000 times thinner than a human hair. It's wild, right?
Wow, 1,000 times thinner. That's pretty tiny.
Right, I actually learned about it from this episode of Cocktail Party Chemistry, episode 112. They were talking about how electrospinning uses high voltage electricity to basically pull these like super thin threads out of a polymer solution.
So it's like using electricity to spin superfine threads.
Yeah, exactly. Kind of like imagine a spider spinning silk, but amped up with electricity.
Okay, I'm starting to get the picture, but why are these nanofibers so special? What makes them so different from regular fibers?
Well, one of the biggest things is their surface area. Think about it. If you take something and stretch it out into a super thin fiber, you're seriously increasing its surface area.
Oh, I see. So like if you took a sheet of paper and turned it into a giant ball of yarn.
Yeah, exactly like that. Way more surface area packed into the same amount of material. And that massive surface area, it's a game changer for a bunch of stuff like filtration.
Filtration, huh?
Yeah, just imagine a filter made out of nanofibers. It would have a ton of surface area to trap all those tiny particles, making it way more efficient than those regular filters.
Mm. That's pretty cool. So we could be talking about like next level air purifiers or even super efficient water filters.
Totally. The potential is huge. It's not just filtration, though. That increased surface area makes nanofibers crazy useful in things like catalysis, too.
Catalysis, right? I remember from chemistry class something about speeding up chemical reactions.
Bingo. And because nanofibers have so much surface area, they can act as super efficient catalysts, providing more spot for those chemical reactions to happen.
Oh, I get it. So it's like having a tiny chemical factory with a ton of workstations, all working super fast.
That's a great way to put it. And then there's sensor technology, too. That increased surface area means sensors can be incredibly sensitive, able to pick up on even the tiniest changes in their environment.
Wow, that's amazing. So we're talking about sensors that can detect like pollutants in the air, toxins in water, maybe even tiny changes in our bodies, all thanks to these tiny fibers.
You got it. And you know what else is cool?
What's that?
Electrospinning, the process of making these nanofibers, is actually considered pretty sustainable.
Really? That's great.
Yeah, I remember another episode of Cocktail Party Chemistry, episode 3, the one about green chemistry. They talked about electrospinning being a really good example of how we can use innovative techniques to be more sustainable.
That makes sense. So it's not just about the amazing applications, it's about doing it in a way that's good for the planet too.
Exactly. A win-win situation.
Totally agree. So are you ready to dive into some of the really exciting specific applications? You mentioned biomedical scaffolds earlier, right?
Oh yeah, that's where my mind went right away. I remember in that episode 112 of Cocktail Party Chemistry, they highlighted how flexible these nanofibers are, which seems perfect for building those complex structures that can support the growth of new tissues.
You're right, and that flexibility is key because it lets the scaffolds fit to the shape of the body and integrate with existing tissues better.
It's like creating a custom-made support system for cells to grow and thrive on. The implications for regenerative medicine are huge, don't you think?
Absolutely huge. Imagine repairing damaged organs, rebuilding bones, or even growing new tissues from scratch, all thanks to these tiny, flexible scaffolds.
It's pretty mind-blowing when you think about it.
It really is. And you know what else is great? They mentioned in episode 112 that electric spinning is also a pretty cost-effective way to make these advanced materials.
Really, that's amazing, especially in medicine where cost could be such a big barrier.
Exactly. The fact that electrospinning is relatively affordable means that this technology could become more widely available, which could lead to even faster development and broader applications.
That's incredibly exciting. So we're talking about a technology that's not just super powerful and versatile, but also sustainable and affordable.
You got it. And this is only the beginning. There's so much more to explore with nanofibers, and I think you're going to be amazed by what we uncover next. But, even though all this sounds super promising, there are always some challenges that pop up when you're working with new tech, right? Like researchers are still trying to figure out a few things with nanofibers.
Yeah, that makes sense. I can imagine that taking these microscopic fibers and actually turning them into something, usable on a large scale probably comes with some hurdles. So what are some of the big ones?
Well, one of the main things is scaling up production. So electrospinning, it works really well when you're making small batches of these nanofibers in the lab, but when you want to produce them like on a massive scale, things get a bit tricky.
It's kind of like baking, right? You can easily double a recipe, no problem. But if you try to multiply it by 1,000, you might run into a few issues.
Yeah, exactly. Maintaining that same level of quality and making sure they're all uniform, it becomes a much bigger challenge when you're trying to produce tons of them.
I can see how that would be a major roadblock, especially for industries that need a lot of these materials, like companies making those super filters we talked about.
For sure. And another thing is the durability of these materials. Nanofibers are crazy strong for their size, don't get me wrong, but they can kind of break down over time, especially in tougher environments.
So think about those biomedical scaffolds we were talking about. They have to be strong enough so they can actually support cell growth, but then they also need to break down safely and completely once the tissue is all fixed up.
Exactly. It's like walking a tightrope. Scientists are always trying to find those perfect materials and that ideal nanofiber structure so they can create scaffolds that are both strong and biodegradable.
Sounds like a pretty complicated puzzle.
Oh, it definitely is. And that actually brings us to another challenge, cost. Even though electrospinning is generally seen as cost effective, producing some of the more specialized nanofibers, well, that can get expensive.
Yeah, that makes sense, especially if you're using really complex materials or if you need to modify the fibers in certain ways to get those specific properties. I can see how that would add up.
Exactly. So while we're all dreaming up these incredible applications, we also need to find ways to make them affordable and accessible to everyone.
You're totally right. It's awesome to have a brilliant idea, but if it's not affordable, it's not really going to help as many people as it could.
Absolutely. And that's why there's so much research happening right now. Researchers are trying to find new, more efficient ways to produce them, and they're also exploring different materials that might be a bit easier on the wallet.
It's exciting to see that scientists are really tackling these issues head on. And, I have a feeling that as technology keeps getting better, the costs are going to go down, and that'll open up even more possibilities for using nanofibers in all sorts of cool ways.
I totally agree. But hey, we can't forget about safety either, right? Every time you start working with a new material, especially one that might end up being used inside the human body, you have to make absolutely sure it's safe.
That's a really good point. I remember in episode 112 of Cocktail Party Chemistry, they talked about how scientists are doing a bunch of research to make sure nanofibers are biocompatible.
Yeah, exactly. We got to figure out how these materials interact with living cells and tissues, both in the short term and over a long period, just to be certain they won't cause any unexpected problems.
It's definitely reassuring to know that safety is such a high priority. After all, we don't want to create a solution that accidentally creates new problems down the line.
Exactly. And that focus on safety, it's not just for biomedical applications either. It applies to any area where nanofibers might come into contact with people or with the environment.
So for those air and water filters we talked about, we need to make sure that the nanofibers themselves don't release anything harmful into the air or water.
Exactly. It's all about looking at the entire life cycle of these materials, from creation to disposal, and making sure they're being used responsibly every step of the way.
I'm really glad that sustainability and safety are built into nanofiber research and development right from the start. It gives me a lot of hope that this technology can really make a positive impact on the world.
I share your optimism. But hey, let's get back to what I know you're really interested in, those biomedical applications. Are you ready to dive deeper into the world of how nanofibers can revolutionize medicine?
Oh, absolutely. This is the part I've been waiting for. The idea that these tiny fibers can change the face of medicine is just mind-blowing to me.
Well, one area where they're showing a ton of promise is in drug delivery. Imagine, packaging up a drug inside a nanofiber and then delivering it right to the exact spot in the body where it's needed.
Whoa, that's amazing. So instead of flooding the whole body with medication, you could just target the problem area directly.
You got it. And that targeted approach could make treatments way more effective. And it could also reduce potential side effects because you're not exposing healthy tissues to as much of the drug.
Makes total sense. I can definitely see how that would be huge for treating things like cancer, where you want to get the chemo drug straight to the tumor cells without affecting the rest of the body.
Exactly. And the cool thing is, it's not just for cancer. Scientists are trying out nanofiber-based drug delivery for all sorts of diseases like infections and neurological disorders.
It's almost like having a microscopic postal service that can deliver those tiny packages of medicine right to the address inside the body.
Aha, that's a great way to think about it. And it gets even cooler. We can actually design nanofibers to release the drugs at a specific rate, so the treatment is delivered over a controlled period.
So it's not just about getting the drug to the right place, it's about making sure it's released in the right amount and at the right time to really be effective.
Exactly. And that level of control is super important for so many different types of treatments.
It's really incredible to think that something so small can be such a complex delivery system.
It really is, but wait, there's more. Researchers are even looking at ways to put sensors inside those nanofiber scaffolds.
Wait, sensors inside the scaffolds, what would those even do?
Okay, so they could keep tabs on how much drug is being released and how the surrounding tissues are reacting to the treatment. And get this, all in real time. It's like a feedback system built right into the delivery system.
No way, that's insane. It's like having a tiny doctor right there inside your body, making sure everything's going according to plan.
Haha, that's a great way to put it. And this kind of real-time feedback, it could completely change how we approach personalized medicine. Doctors could adjust treatment plans on the fly, tailoring them to the specific needs of each patient.
I'm seeing so much potential here. But tell me, are any of these drug delivery things actually being used in medicine right now? Or are they still in the research phase?
Well, a lot of them are still being developed, but there are definitely some really exciting examples of nanofibers already making a difference in the medical world.
Okay, you got to spill the beans. I want to hear about real-life examples of this tech changing lives.
One area where nanofibers are already shining is in wound healing.
Oh yeah, wound healing. I remember reading about that. They're making like super advanced bandages, right?
Yep, exactly. Those nanofiber-based dressings have a few advantages over the regular ones.
Okay, I'm all ears. What makes them so special?
Well, for one thing, they have this porous structure that allows for better air circulation, which actually helps wounds heal way faster.
So it's like the wound can breathe easier.
Haha, pretty much. And get this, we can actually design nanofibers to copy the natural structure of tissues in our bodies, so they kind of act in a scaffold for the cells to grow on and rebuild that damaged tissue.
It's like giving the cells a blueprint to follow, helping them rebuild the wound in a more organized and efficient way.
That's a great analogy, and we can even put things like antimicrobial agents or other therapeutic compounds right into these dressings, which can help even more with healing and prevent infections.
So it's like taking the basic idea of a bandage and turning it into this high-tech healing system.
You got it. And this goes beyond just like cuts and scrapes. These nanofiber scaffolds are also showing a ton of promise for treating chronic wounds like biomedical ulcers, which can be super tough to heal.
Whoa, that's huge. I can only imagine how much that could help people who are struggling with those kinds of wounds, which can really affect their lives.
It's definitely a really promising area of research. And beyond wound healing, scientists are also looking at using nanofibers for bone regeneration.
Okay, now things are getting really interesting. I've heard a little bit about this, but tell me more about how it actually works.
So picture this. You have this nanofiber scaffold, right? And it's bridging a gap in a broken bone, acting like a framework for new bone tissue to grow on.
It's like building a tiny little bridge to help the bone reconnect and heal the right way.
That's a great way to visualize it. And because we can make these scaffolds to have the same porous structure as real bone, they create this perfect environment for the bone cells to attach, grow, and do their thing.
So it's not just about holding the bones together, it's about creating the perfect little space for those cells to thrive and rebuild the bone.
Exactly. And to give them a boost, we can also add things like growth factors or other bioactive molecules to the scaffolds, which can really speed up bone regeneration.
It's like creating a tiny construction zone inside the body, giving those bone cells everything they need to do their job.
Haha, I love that analogy. And the coolest part is this approach isn't just for bone. Scientists are exploring the potential of nanofibers to regenerate all sorts of tissues, from cartilage to tendons, even neural tissue.
That's insane. It's like having this toolbox full of tiny building blocks that can be used to repair and regenerate almost any part of the body.
That's a fantastic way to put it. And as research continues, I have no doubt we're going to see even more creative ways to use nanofibers in medicine and beyond.
Okay, bring it on. What other awesome applications are out there? What about applications outside of medicine? What are those looking like?
Well, one area where they're making a splash is in energy storage.
Oh, energy storage. That's a big one, especially now with all the focus on renewable energy sources like solar and wind.
Yeah, exactly. And nanofibers are showing a lot of potential for making batteries and supercapacitors work even better.
Okay, I'm hooked. Tell me how these tiny fibers are changing the game for energy storage.
Remember all that talk about the massive surface area of nanofibers?
Oh yeah, that seems to be the secret weapon for a lot of their applications.
Well, in energy storage devices, that huge surface area allows ions, which are those little charged particles that carry electrical current, to move around way more efficiently.
So it's like creating a superhighway for the ions to zoom around inside the battery or supercapacitor.
That's a perfect analogy. And that better ion transport, it can actually lead to faster charging and discharging rates, and it can also increase the amount of energy the device can hold.
So imagine being able to charge your phone or your electric car in like a fraction of the time it takes now.
That's the dream, and with nanofibers, it might actually be possible. Plus, researchers are looking at ways to use nanofibers to make energy storage devices more flexible and lightweight.
Whoa, flexible batteries. That would be a game changer. Think about all the possibilities. Wearable electronics, lighter, and more efficient electric vehicles.
The possibilities are endless. But let's not forget about environmental science. Remember how effective nanofibers are for filtration.
Of course, like a microscopic net that can catch even the tiniest particles.
Right, and that makes them perfect for purifying water and cleaning up the air.
So those water filters we talked about earlier, they can be taken to a whole new level with nanofibers. Imagine being able to filter out even the smallest contaminants, like bacteria and viruses.
Exactly, and they could be used in air filters too, trapping pollutants and allergens and making the air we breathe cleaner, both indoors and outdoors.
That would be so helpful, especially in places with a lot of air pollution like big cities or industrial areas.
You're absolutely right. And beyond just filtering, nanofibers can also be used for environmental remediation, which is basically cleaning up the messes we've made.
Okay, I'm curious. Tell me more about how they're cleaning up the environment.
Imagine nanofibers being used to make materials that can soak up oil spills or even remove heavy metals from contaminated water.
That's amazing. It's like having a tiny army of environmental superheroes cleaning up after us.
Haha, that's a great way to put it. And because we can actually fine-tune the chemical properties of nanofibers, we can design them to target specific pollutants, which makes them even more effective for environmental cleanup.
I love the idea that something so small can have such a big impact on cleaning up our planet. It's pretty inspiring.
It really is, and it shows how creative and resourceful scientists can be when it comes to using nanofibers to tackle some of the toughest environmental challenges we face.
It's incredible to think that something we can barely even see has the potential to change so many aspects of our lives.
You're telling me these tiny fibers are like these hidden superheroes quietly working to improve our health, make our energy systems better, and even seal our planet.
Ha ha, I love that analogy. But I'm curious, are there any other applications of nanofibers that we haven't been touched on yet? Like any unexpected or surprising uses?
Well, one area that might surprise you is how nanofibers are being used in textiles.
Wait, textiles, like clothes and fabrics. I never would have thought of that.
I know, right? It might seem a bit strange at first, but nanofibers are actually changing how we think about fabrics in a big way.
Okay, you've definitely piqued my interest. Tell me everything. How are these tiny fibers changing the clothes we wear?
Imagine fabrics that are super lightweight but crazy strong, fabrics that let you breathe but also keep you dry, and even fabrics that can sense and react to changes in the environment.
That sounds like something straight out of a sci-fi movie. Are we talking self-cleaning clothes? Or clothes that change color depending on your mood?
Haha, those might be a bit further down the road, but for now, nanofibers are being used to make fabrics work better in a lot of different ways.
Okay, give me some real-world examples. How are these high-tech fabrics being used today?
One example is in sportswear. Nanofibers can be used to make fabrics that wick away moisture, which keeps athletes cool and dry even when they're working up a sweat.
So it's like having a built-in air conditioner in your clothes. I'll take one of those.
And because they can be incorporated into breathable membranes, they can also make fabrics that are both waterproof and breathable, which is perfect for outdoor gear like rain jackets and hiking boots.
That would be a game changer for anyone who loves being outside, especially in unpredictable weather.
Totally. And it's not just for athletic wear. Nanofibers are also being used in protective clothing for firefighters, soldiers, and medical workers.
Whoa, that's intense. So imagine clothing that's resistant to flames, chemicals, or even bacteria and viruses, but it's also lightweight and breathable enough to be comfortable and let you move around freely in high-pressure situations.
That's the goal, and some researchers are even trying to develop nanofiber-based fabrics that can detect and neutralize harmful substances.
Now that's what I call a superhero suit. It's crazy to think that something so tiny can have such a huge impact on how we design and create the materials we use every single day.
I know, right? It's a testament to how creative and innovative researchers can be when they're exploring the potential of nanofibers.
I can't wait to see what the future holds for nanofiber tech. It feels like every day there's a new discovery or application that pushes the limits of what we thought was possible.
It's definitely a super dynamic and innovative field. And the fact that it brings together people from different areas of science, chemists, biologists, engineers, that's what makes it even more exciting.
It's like they're all speaking of scientific languages, but they've found this common ground in the world of nanofibers.
That's a beautiful way to put it. And that common ground, it's where the real magic happens. It's where different perspectives come together to create something truly groundbreaking.
I love that. And it actually makes me think about something we talked about earlier, the importance of sustainability as we develop new technologies.
Yes, absolutely. That's something we can't afford to overlook, especially with the technology as potentially powerful as nanofibers.
As we keep exploring what's possible with this technology, we need to make sure we're doing it in a way that benefits both people and the planet.
Couldn't agree more. And I'm glad to say that there are a lot of researchers out there who are focused on finding sustainable ways to produce nanofibers and ways to reduce their environmental impact.
That's awesome to hear. It gives me even more hope that this technology can be a real force for good in the world.
I'm right there with you. But hey, I think it's time to shift gears a bit. Let's talk more about those advanced materials that we touched on earlier.
Yeah, let's dive into that. I'm ready to hear about more of those mind-blowing applications.
So tell me, what specifically about advanced materials has got you curious?
Well, we've covered a lot, from filtration to energy storage to wound healing, but I'm curious about any other uses for nanofibers that we haven't discussed yet. What else are they being used to create? What else is out there?
Okay, well, how about this? Nanofibers are being used to create flexible electronics.
Hold on, flexible electronics. That's something I never even considered.
It's like something straight out of science fiction, but it's becoming a reality. We're talking about electronics that can bend, stretch, and mold to practically any shape you can imagine.
Wow, that's incredible. I can see how that would be awesome for things like flexible screens, for phones and tablets. But what other possibilities are there?
Well, imagine wearable sensors that you could weave into your clothes or even implant under your skin to track your vital signs, monitor your fitness, or even deliver medication.
That's wild. It's like having a personal health tracker built right into your life.
Exactly, and it goes way beyond just healthcare. Flexible electronics have the potential to transform robotics, aerospace, even the fashion industry.
Okay, I need to hear more about this. How are nanofibers making these flexible electronics possible?
Well, it all boils down to those unique properties we've been talking about. Nanofibers can be incredibly conductive, which means they can carry electrical signals really well.
So it's like having tiny flexible wires woven into a fabric.
You got it. And because they're so lightweight and easy to form into thin films, they're perfect for making electronics that are both flexible and tough.
It sounds like they're the ideal building blocks for this new generation of electronics that can move with us and adapt to our bodies.
Exactly. And the possibilities are only limited by our imagination.
So we're talking about flexible solar panels that could be built into clothing or backpacks, electronic displays that can be rolled up and put away, even sensors woven into fabrics to create interactive clothing. The possibilities are endless.
Absolutely. And with the incredible speed at which research is happening in this field, I'm sure we'll be seeing some mind-blowing applications of flexible electronics pretty soon.
Wow, this entire deep dive into nanofibers has been incredible.
It's been a real adventure exploring the science, the potential, and all the amazing things these tiny little fibers can do.
I feel so energized and inspired by everything we've talked about.
And as you continue exploring, I encourage you to think about the broader impacts of this technology too. Think about the societal and ethical implications.
That's a really important point. Anytime we're dealing with powerful technology, we have to make sure it's being used for good and that its benefits are accessible to everyone.
Absolutely. As we move forward, we need to have open and honest discussions about the potential risks and rewards of nanofibers and make sure we're including diverse voices as we develop and use them.
So it's not just about the science itself, it's also about thinking through the broader consequences and making sure that this technology is used ethically and benefits everyone.
Well said. And I have no doubt that you, with your curious and thoughtful approach, will continue to explore those important aspects of nanofiber technology.
This has been another incredible deep dive. We've covered so much ground, from the basics to the incredible applications, and it's clear that nanofibers have a bright future ahead of them.
It's been a pleasure joining you on this journey of exploration.
And before we wrap things up, I want to leave you with one final thought to ponder.
I'm all ears. What thought-provoking question do you have for our listeners?
Well, we've talked about how nanofibers are already being used to tackle some of the biggest challenges we face in areas like health, energy, and the environment.
Absolutely. It's been amazing to see how these tiny fibers are already making a real difference in the world.
But here's the question. What other challenges could nanofibers help us overcome? What problems are you passionate about solving? What innovative applications can you imagine that could make a positive impact on the world?
Yeah, let your imagination run wild. We can't wait to hear what groundbreaking ideas you come up with.
All right, we're back for the final stretch of our deep dive into nanofibers. I gotta say, my mind is still spinning from all the amazing things we've learned.
It's been an incredible journey for sure. And like we've said before, we've only scratched the surface of what these tiny fibers can do.
Speaking of scratching the surface, I think it's time we tackle that one big question that's probably on everyone's mind. We've talked a lot about all the amazing things nanofibers can do, but how do we actually make this stuff work in the real world?
Ah, you're talking about scalability.
Exactly. I mean, it's one thing to create these amazing materials in a lab, but how do we go from that to mass production? How do we make sure nanofibers can be produced efficiently and affordably enough to meet the needs of industries like healthcare, energy, and all those areas where they have so much potential?
That's the challenge, isn't it? And it's something that researchers are really focused on right now. One promising approach is to develop new manufacturing techniques that can really ramp up production without sacrificing the quality and precision that we need.
So it's like finding that perfect balance between making a lot of nanofibers and making sure they're all top-notch.
Exactly. It's a delicate balancing act for sure. And it's not just about the manufacturing process itself. We also need to think about sourcing the materials, figuring out the best electrospinning parameters, and developing really solid quality control measures to ensure that every batch of nanofibers is consistent and meets the required standards.
It sounds like there are a lot of moving parts to consider when we're talking about bringing nanofibers to the masses.
Absolutely. And it's not just about making more nanofibers, it's about making them smarter, more functional. That's where things like surface modification come into play.
Surface modification, now that sounds interesting.
Basically, it's a way to tweak the surface of the nanofibers to give them specific properties. We can attach different molecules or chemical groups to the surface, which can make them more compatible with living tissues, more water resistant, or even give them specific electrical or magnetic properties.
So it's like giving them superpowers, tailoring them for specific jobs. That opens up so many possibilities.
You got it. And with these more advanced capabilities, we can start thinking about applications that go way beyond what we've already talked about. We can start imagining nanofibers that can deliver drugs with even greater accuracy, sensors that can detect the tiniest traces of pollutants, even materials that can heal themselves when they get damaged.
Now that's some next level stuff. It sounds like the future of nanofibers is all about pushing those boundaries and creating materials that can solve problems we haven't even thought of yet.
Absolutely. And the best part is, this is really just the beginning. Research and development in this field is moving so fast, and I have no doubt that we'll be seeing some truly mind-blowing advancements in nanofiber technology in the very near future.
Well, this deep dive into the world of nanofibers has been absolutely incredible. I'm leaving this conversation feeling so inspired and hopeful about the future.
It's been a real pleasure exploring this with you. And remember, the future of nanofibers is in our hands. Let's keep asking questions, keep pushing those limits, and keep using our imaginations to create a better world with these amazing tiny fibers.
This has been The Deep Dive. Thanks for joining us. CCA.